Hello, and welcome to our video on Docker Introduction, revolutionizing application development and deployment. In this video, we will be providing you with a comprehensive overview of Docker and its significant influence on the software development process. Docker is a platform for developing, shipping, and running applications. It's often referred to as containerization technology because it allows you to package an application and its dependencies into a standardized container image. These containers are isolated and can run consistently across different environments, making it easier to develop, test, and deploy software. Section 1. What is Docker? Docker is an open-source platform that allows you to build, package, and distribute applications as lightweight, portable containers. Containers are isolated and self-sufficient, encapsulating the necessary dependencies and libraries required for an application to run consistently across different environments. Section 2. How does Docker work? Docker utilizes a client-server architecture, where the Docker client communicates with the Docker daemon, which is responsible for building, running, and distributing containers. Docker images serve as the basis for containers, providing a snapshot of a pre-configured application environment. One of the key features of Docker is its ability to share and reuse images through container registries like Docker Hub, allowing developers to save time and effort. Section 3. Benefits of Docker in application development. Docker offers numerous benefits in the application development lifecycle. With Docker, developers can achieve greater scalability and efficient resource utilization by running multiple containers on a single machine. Additionally, Docker promotes consistency across different environments, enabling seamless deployments and reducing the infamous "works on my machine" problem. By encapsulating dependencies, developers can avoid conflicts and ensure consistent performance. Section 4. Docker in the software development process. Docker plays a pivotal role in the software development process. It facilitates collaboration by ensuring that different team members work on the same application environment. Through Dockerizing applications, developers can reduce deployment challenges, as containers provide a consistent runtime environment. Moreover, Docker's versioning and rollback capabilities enable easy experimentation and rollbacks, fostering innovation and agile development practices. Section 5. Real-world applications and success stories. Docker has gained immense popularity and has been adopted by various industry giants. Many organizations have experienced faster and more cost-effective application development and deployment using Docker. Examples include companies like PayPal, Spotify, and Uber, who have improved their development cycles and decreased time to market. Docker has proven to be a game-changer, enabling organizations to respond to market demands swiftly. In summary, Docker is a powerful technology that simplifies the development and deployment of applications by using containers. It promotes consistency, portability, and efficiency, making it a valuable tool for both developers and operations teams. Docker has a specific terminology that you should be familiar with to work effectively with Docker. Here are some key Docker terms and their explanations. Container. A lightweight, standalone executable package that includes everything needed to run a piece of software, including the code, runtime, system tools, libraries, and settings. Docker image. A read-only template containing a set of instructions for creating a Docker container. It includes the application code, runtime environment, and dependencies. Docker container. An instance of a Docker image that is running as a process. Containers are isolated from each other and share the host OS kernel. Docker file. A text file that contains a set of instructions for building a Docker image. It specifies the base image, application code, dependencies, and configuration. Docker Hub. A public repository where Docker images are stored and can be shared with others. You can also create private repositories on Docker Hub for your own images. Registry. A storage and distribution service for Docker images. Docker Hub is a popular public registry, but you can also set up private registries for your organization's use. Docker Compose. A tool for defining and running multi-container Docker applications. It uses a YAML file to specify services, networks, and volumes required for an application. Docker Swarm. A native clustering and orchestration solution for Docker. It allows you to create and manage a swarm of Docker nodes for deploying and scaling services. Kubernetes, an open-source container orchestration platform for automating the deployment, scaling, and management of containerized applications. Docker daemon, a background service that manages Docker containers on a host system. It listens for Docker API requests and performs container-related tasks. Docker client, the command line interface (CLI) tool that allows users to interact with the Docker daemon. It sends commands to the Docker daemon via the Docker API. Volume, a Docker feature for persisting data generated by containers. Volumes can be mounted into containers, allowing data to survive container restarts or removal. Network. Docker provides networking capabilities to allow containers to communicate with each other or the external world. Docker creates default bridge networks, but you can create custom networks for more control. Registry authentication, the process of providing credentials, usually a username and password, to access a private Docker registry or repository. Swarm service. In Docker Swarm, a service is a definition of the tasks to execute on the manager or worker nodes. Services define how containers should behave in terms of scaling, placement, and updates. Docker stack, a way to deploy a collection of services as a single unit using a Docker Compose file in a Docker Swarm. Docker engine, the core component of Docker that includes the Docker daemon, server, and the Docker client, CLI. Node. In a Docker Swarm, a node is a physical or virtual machine that participates in the cluster. Nodes can be managers, control plane, or workers, execute containers. Overlay network, a type of network in Docker Swarm that allows containers running on different nodes to communicate with each other as if they were on the same network. Container orchestration, the automated management, scaling, and deployment of containers, typically performed by tools like Docker Swarm or Kubernetes. These are some of the fundamental terms you'll encounter when working with Docker. Understanding these terms is essential for effectively using Docker to package, deploy, and manage containerized applications.